Hi guys, welcome to my channel. In this video, let me explain the syntax directed definition and syntax directed translation. It is also known as SDD and SDT. Before understanding SDD and SDT, we should understand one important idea. A compiler does not only check whether a program follows the correct syntax, it also needs to understand the meaning of the program and translate it into another form. SDD and SDT provides the techniques for connecting the grammar of the programming language with its semantic information and translation process. Let us go in detail with the slides and let us understand. The agenda of today's presentation, these are the topics we'll cover. Introduction. Let us first understand what syntax directed translation means. When we write the program, the compiler first needs to check whether the program follows the grammar of the programming language. For example, if I write A plus B star C, the compiler needs to understand the structure of this expression. But checking the syntax is not enough. The compiler also needs to determine the meaning of the expression, performs the type checking, calculate the values when required, and eventually generates the intermediate or target code. Syntax directed techniques allows us to associate semantic information with grammar production. There are two important techniques we will discuss in today's session. Syntax directed definition, that is SDD, and syntax directed translation, that is SDT. Let's move on to the next slide. Why do we need SDD and SDT? For example, A equals B plus C into D. The parser can determine that this is valid assignment statement and can build a structure for it. But the compiler still has the several things to determine. For example, it needs to know the type of B, C, and D. It needs to understand the multiplication should perform before addition because the operator precedence. It may also need to generate the intermediate code. For example, T1 equals C into D, T2 equals B plus T1, A equals T2. So the grammar tells us about the structure, while syntax directed techniques help us to attach the meaning and translation action to the structure. That is why SDD and SDT are important. Let's move on to the next slide. Syntax directed definition. An SDD is a context free grammar with attributes and semantic rules. Attributes are associated with grammar symbols. Semantic rules are associated with grammar production. So the structure is context free grammar plus attributes plus semantic rules. An SDD describes what information needs to be computed from the syntax. Hope you guys understood. Components of SDD. An SDD has three important components. The first is grammar production. For example, E produces E plus T. This describes the syntax of an expression. The second component is attributes. The attribute stores the information related to the grammar symbols. For example, e.val can store the value of an expression. The third component is semantic rules. Semantic rules tells us how these attributes are calculated. For example, e.value equals e1.val plus t.val. So whenever these production e produces e1 plus t is used, the rule tells us how to obtain the value of e. Therefore, the three main components are grammar, attributes plus semantic rules. hope you guys understood. Let us move on to the next slide. Attributes. And attributes is the property associated with the grammar symbol. It is nothing but it is basically a property or piece of information which is associated with the grammar symbol. There are the two main types of attribute. One is synthesized attribute, another one is inherited attribute. A synthesized attribute gets its values from the children of a node. So the information generally moves upward from child to parent. An inherited attribute gets the information from the parents or from neighboring symbols. So the information can move downwards or from one part of the parser tree to another. A simple way to remember this is synthesized means the information comes from upwards. Inherited means the information comes from the parents or surrounding context. I hope you guys understood. Synthesized attributes. Let's look more closely to synthesized attributes. A synthesized attributes is calculating using the attributes of the children of a node. Consider E produces E1 plus T, and semantic rule is E dot val equals E1 dot val plus T dot val. Suppose our expression is 3 plus 5. The left expression as the value of 3 and T as the value of 5. Therefore, E dot value equals 3 plus 5 equals 8. Notice that the value of the parent node E is calculated using the values of its children. Therefore, the information moves from the left children towards the parent. This is why it is called a synthesized attribute. I hope you guys understood. Let us move to the next slide. Inherited attributes. Now let's look at inherited attributes. An inherited attribute receives the information from the parents or from the neighboring symbol. A common application is processing declaration. For example, consider int a, b, c. The keyword int tells us the type of all the identifiers that follow. Conceptually, we can represent this as D produces TL, where T represents the type and L represents the list of identifiers. If T dot type equals int, then we can pass the information to L. L dot in equals T dot type. So L receives the information that is identifiers should have type integer. This is the example of inherited attributes. Inherited attributes are useful when the information needs to be passed from the parents or from an earlier part of the syntax. Useful for type information, scope information, and declaration processing, and also useful for other context sensitive information. I hope you guys understood. Let's move on to the next slide. Now we have another important concept called an S-attributed definition. An S-attributed definition is an SDD that uses only synthesized attributes. For example, E produces E1 plus T with E dot val equals E1 dot val plus T dot val. Here the values of E is calculated from its children. There are no inherited attributes. Yes, attributed definition are relatively simple and are naturally suited to bottom-up parsing, especially LR parsing. So whenever you hear S attributed, remember S stands for synthesized. It means SDD contains only the synthesized attributes. Next, we have the L attributed definition. L attributed definition are more general than S attributed definition because they can contain the inherited attributes, but those attributes must follow the certain restrictions. The important idea is that inherited attributes of the symbol can depend on information from its parents and from the symbol to its left. This is useful because parsing often proceeds from left to right. For example, in declarations such as int a comma b comma c, the type information int can be passed through the earlier part of the declaration to the identifiers that follows. L attributes definition are particularly useful with the top-down and left-to-right parsing. So remember, S attributes, only synthesized attributes, L attribute, synthesized attribute plus restricted inherited attributes. I hope you guys understood. Advantages are suited to the top-down parsing technique, can be evaluated during the left-to-right traversal, useful for the declaration and type processing. I hope you guys understood. Worked example, expression evaluation. Now let's take a complete example of SDD. Suppose we have this grammar, E produces E1 plus T. E produces T. T produces num. We associated an attribute called val with E and T. The semantic rules are E dot val equals E1 dot val plus T dot val. E dot val equals T dot val and T dot val equals num dot lexwell. I hope you guys understood. Here, lexwell represents the numerical value obtained from the input token. Suppose the input is 3 plus 5. The first number gives us the value of 3. The second number gives us the value of 5. Finally, the semantic rules calculates E dot val equals 3 plus 5, which gives us 8. So the example demonstrates how an SDD can be used to calculate the value of an expression. Let's move on to the next slide. Syntax directed translation. Let's move on to SDD to SDT. Syntax directed translation is a technique where semantic actions are directly embedded into a grammar productions. These actions are usually written inside the curly braces. For example, E produces E plus T, curly brace, open curly brace, print plus close curly brace. The action print plus is executed at the particular point during parsing. Similarly, T produces num. Print num dot lexval can print the value of the number. So unlike SDD, where we describe semantic rules separately using the attributes, SDT places executable action directly inside the grammar. Therefore, we can remember SDT equals grammar plus embedded semantic action. I hope you guys understood. Let us move on to the next slide. SDT example. Infix to postfix. Let's understand SDT with a practical example. Suppose the input is the infix expression 3 plus 5. We want to convert it into a postfix notation. The postfix forms is 3 5 plus. The SDT contains the actions that prints the operands and operators at appropriate points. When the parser reads 3, it prints 3. When it reads 5, it prints 5. After the operands have been processed, the action associated with the plus operator. prints plus. Therefore, the output becomes the 3 5 plus. The important point here is that the position of the semantic action determines where it is executed. This is the one of the key idea behind the syntax directed translation. I hope you guys understood. Let us see the SDD versus SDT. The full form is SDD, syntax directed definition. SDD was nothing but syntax directed translation. Main concept attribute for SDD. SDT, the main concept is semantic action. Rules are like separate semantic rules. For SDT, embedded in grammar, focuses what should be computed. For SDT, when action is performed. The nature of SDD more declarative. The nature of SDT more implementation oriented. Evaluation of SDD attributes evaluation. Evaluation of SDT action execution. SDD common use semantic analysis, where SDT common use translation or code generation. The one of the memory trick is SDD defines the meaning, where SDT performs the translation. I hope you guys understood. Let us see the applications. SDD and SDT has mainly applications in compiler construction. The first application is expression evaluation. For example, calculating the value of 3 plus 5, which produces 8. The second is type checking. The compiler can use the semantic information to determine whether the operations are valid. For example, it can check whether two operands are compatible for a particular operation. The another important application is intermediate code generation. For example, T1 equals C into D, T2 equals B plus T1. SDD and SDT can also be used for constructing the syntax trees, passing symbol tables, handling the declaration, and supporting the code generation. Therefore, these techniques plays a very important role between the syntax analysis and later stages of the compilation. I hope you guys understood. Let's move on to the next slide. Advantages and limitations. Now let's discuss the advantages. The first advantage is that SDD and SDT provides semantic way to connect the syntax with semantics. They are useful to the expression evaluation, type checking, intermediate code generation, and other compiler tasks. They also make more compiler designs more organized because semantic process can be associated with grammar production. However, there are some limitations. When the grammar has many attributes, their dependencies can become complicated. The order in which attributes or actions are evaluated can also become important. Inherited attributes may make implementation more difficult. And for a very large grammar, maintaining many semantic rules and actions can become complex. So they are powerful techniques, but they need to be designed carefully. I hope you guys understood. Let's move on to the summary and conclusion. To conclude today's presentation, let's quickly revise the important concepts. The syntax directed definition, which combines the grammar with the attributes and semantic rules. Attributes can be synthesized or inherited. Yes attributes. SDD uses only synthesized attribute. L attribute, SDD, allows restricted inherited attributes. SDT embeds the semantic action directly into the grammar production. Both SDD and SDT helps the compiler to connect the syntactic structure of the program with its meaning and translation. The easiest way to remember the whole topic is SDD, grammar plus attributes plus semantic rules gives the semantic meaning, where SDT, grammar plus embedded semantic action, which gives the translation. I hope you guys understood. If you have any doubts, please raise your doubts in the comment box so that I can respond. Thank you.